Well, hello again, class. This is section 12.1. I know it's been a while since I've posted a video, but hopefully there's enough in this to kind of get you through a working idea of how exponential functions work. We are living in a world where exponential growth has never been more prevalent. But this right here is a general idea of an exponential growth model. You have an A times B raised to the x minus h plus k, and each of those things has a meaning here. B is your base, it's what you're doing. If B happens to be 2, then you're doubling repeatedly. If B were a 3, you'd be multiplying by 3 repeatedly. The A value that multiplies here is the y-intercept, your starting value. If you start with $4 in a bank account and you repeatedly double it over time, then that's your starting value. H is a horizontal shift, just like in parabolas. K is your vertical shift, again, just like in parabolas. There's a lot of things we can make note about these, but I want to show you how to do some graphing in Desmos. I don't know if you've ever used Desmos before, but just go to Desmos, DESMOS.com, click Start Graphing. Let me show you what you can do with this, including some pretty cool ideas of sliders. I'm going to type in y equals a times b raised to the x minus h plus k. And I'm going to add sliders a, h, k. And let's see, I guess I need a different b value, don't I? Let me change this b value now to a 2. And now we can see what our graph looks like, depending, of course, on our a, h, and k. If our a value is a certain starting value, if our k is a certain value, let me move the k down to 0. And my h down to 0. And this is your standard looking exponential curve. You can see that depending on what the a value is, it might start at 5. What if it starts negative? Well, then it's going to go down, be reflected. And if I have these different k values, I can shift this thing up and down, or I can shift this thing back and forth. So that is the basic idea. So if I want to graph this thing here, 5 times 2 to the x minus 1 plus 4, I could just set my a value to 5. I could set my k value to 4 and my h value to 1, and that would give me what this graph looks like. Of course, we don't need to do any of this stuff. We could just graph y equals 5 times. By the way, to do the times, I'm doing Shift 8 as an asterisk. And then 2 raised to the, and I found that you need to put parentheses to keep this value up here. X minus 1, close your parentheses, and then arrow over to the right to move out of the exponent and do a plus 4, and then we have our graph just like that. There's all kinds of different things we could do with these graphs. I looked through the homework. I thought the homework was pretty straightforward, pretty easy, some vocab stuff. There was a difficult question perhaps with the compound interest quarterly versus continuously. I think the example in the homework, the view an example, does a pretty good job of explaining that. The whole idea of the E value, what is all that about? E is a very powerful number that really has its power based on calculus and not really here. Just know that E is an amazing number, very similar to pi. The fact that it is a constant, it goes on forever, never stops, never repeats. And when we get to the natural logarithm with the logs, then it will take more, have more importance then. All right, email me with questions.